How to oversee an organization's portfolio of software-intensive projects as part of a business strategy. The first step is to diagram the anatomy of each project. Diagramming the anatomy of a project demands the right mix of generalist and specialist skills that combine both interconnecting parts and depth of knowledge. Diagramming the anatomy of a project, expressed in terms of essence alphas, is helpful in determining the value of applicants to the organization. It begins by focusing on the customer in terms of stakeholders and the opportunity value proposition. It goes on to frame the solution in terms of requirements and the software architecture in terms of parts and their relationship. It finishes up by framing the endeavor in terms of the team, the way of working, and the status of the work itself. With the anatomy of the project diagrammed in terms of alphas, staffing can proceed along the lines of program management experience, up-to-date technical knowledge, and project management experience. More program management experience is needed to understand stakeholders and the opportunity value proposition. More up-to-date technical knowledge is needed to understand requirements and the architecture of parts and relationships. The right blend of experience and technical knowledge is needed to understand the team, way of working, and work progress. If each applicant is assessed in terms of these alphas and the needs of the organization, a rational hiring policy can be established and practiced. The CMAT Essence Kernel Framework serves as a useful means to evaluate and assess strengths and weaknesses. The CMAT Essence Kernel is the Swiss Army knife, and the alphas are the blades that make it an all-purpose tool, including stakeholders, opportunity, requirements, software system, way of working, team, and work. Essence is the Swiss Army knife, and the alphas are the blades that make it an all-purpose tool. Like the Swiss Army knife, the values of essence lies in its usefulness. Why? Whether you establish criteria at the beginning of a project or not at all, there exist industrial strength objective criteria for learning the status of a project and pointing the way forward. These criteria can be found in the Software Engineering Method and Theory, CMAT, formulation, and its essence kernel, the essence and common ground of software engineering. What? This common ground of 7 dimensions, termed alphas, is intended to be independent of particular methods, practices, and tools. The alphas possess the capability to reason about progress and assess status of any software project, regardless of method and practice selections, spanning the customer space, the solution, and the endeavor. How? Simple yet powerful. These sensible alphas and their natural states of progression are actually very useful in setting expectations and guiding a project on its way, and in guiding a software industry that has lost its way. More specifically, the alphas and the sequence of their state transitions include: stakeholders are recognized, represented, involved, in agreement, satisfied with deployment, and satisfied in use. The opportunity is characterized as identified, software needed, value established, viable, addressed, and benefit accrued. Requirements are conceived, bounded, coherent, acceptable, addressed, and fulfilled. The software system architecture is characterized as selected, demonstrable, usable, ready, operational, and retired. The team is selected, formed, collaborating, performing, and adjourned. The way of working is characterized as principles established, foundations established, in use, in place, working well, and retired. Work is characterized as initiated, prepared, started, under control, concluded, and closed. The anatomy of two project examples are diagrammed. The one, the Navstar Global Positioning System, the other, the Boeing 737 MAX 8. A close examination of the facts associated with each example is assisted by the application of the 7 alphas. This criteria for strict and close examination spans completeness, correctness, style, and rules of construction. The Navstar Global Positioning System, GPS, is a satellite-based radio navigation system that provides navigation data to GPS-equipped users with which they can determine their three-dimensional position, velocity, and time. Stakeholders include military operators, weapon systems users, commercial transportation users, and public transportation users. The opportunity is intended to deliver accurate and precise navigation data that enable users in land, air, and sea to determine three-dimensional position, velocity, and time. The requirements are to coordinate the Operational Control Station, OCS, composed of Master Control Station, MCS, space segment of operational and spare satellites, ground antennas, and monitor stations. The software system spans the use of state machines, modules, and programs to express computer program configuration items, CPCI, for executive, control and display, ephemeris, clock, space vehicle command status, network control, performance analysis, math library, space vehicle positioning, mission scheduler, scenario generator, and system log. The way of working spans a concept of operations, requirements specifications, incremental design, development, and testing. The team supports land-based operations, program management, systems engineering, software engineering, and test operations. Work is tracked using monthly earned value metrics. The Boeing 737 was redesigned with a new engine and mounting to match the recent Airbus A320 competitive entry. The new engine mounting altered the center of gravity, causing the plane's nose to pull upward and stall the engine. The Maneuvering Characteristics Augmentation System, MCAS, was intended to compensate for the lack of re-engineering. Stakeholders include the divergent interests of the flying public and buying airlines. The public demands safety, and the airlines demand competitive operating cost advantage. Both Boeing and the FAA tilted in favor of airline interests. Opportunity includes the flying public, which would like to take off and land without crashing under all circumstances. This was subordinate to the Boeing need to be competitive against Airbus. The Boeing 737 has a 50-year history. Airbus has a 20-year history. Consequently, Airbus A320 was inherently better positioned to adopt changes and modernize. Requirements include managing the angle of attack, AOA behavior, and providing a stall escape maneuver. The software system includes Maneuvering Characteristics Augmentation System, MCAS, designed to manage OAO behavior. The way of working demands maintaining proper separation of oversight between Boeing and FAA. Oversight was diluted by extreme collaboration. In effect, Boeing and the FAA colluded to corrupt the oversight responsibility, rendering it illegitimate. Team shortfall includes extreme Boeing and FAA collaboration, impacting FAA's oversight responsibility. FAA lacks the engineering capability to perform adequate oversight. Boeing engineers are retiring in greater numbers, and next-generation engineers are not up to the task. Work involved a software patch process rather than the redesign needed. Some questions demand answers. Just when did Boeing offer the safety options that neither of the two crashed airlines chose to purchase? Clearly, Boeing suspected it had a problem when it offered the safety options. Did Boeing offer the additional safety options expecting that some airlines would decline, thereby shifting the responsibility for any incidents to the airlines themselves?